This video introduces significant digits, sometimes called significant figures. A significant digit is a digit obtained by actual measurement. It indicates how precise that measurement is. This is something that is used a lot in physics and in engineering. Trailing zeros to the left of the decimal point are not significant if there are no digits to the right of the decimal point. For example, 243 million has 3 significant digits. So because there isn't a decimal point followed by some kind of number, these trailing zeros are not significant. Trailing zeros to the right of the decimal point are significant. So for example, 5.0 has 2 significant digits, 5.00 has 3 significant digits, and 5.000 has 4 significant digits. So I have a little, trick here I got from one of my physics friends to help us remember how to correctly do significant digits. Now, this is going to require a little bit of U.S. geography. If we've got the United States here, yep, I know, we're strong ever, that the Atlantic Ocean is over here and the Pacific Ocean is over here. We do need to keep that in mind. So if the decimal point is absent, there isn't one, we're going to start at the Atlantic Ocean on the right side of the number and proceed towards the Pacific Ocean, the left. The first non-zero number and everything to the left of that is significant. Now, if there is a decimal point, the decimal point is present, we're going to start at the Pacific Ocean, the left side, and proceed towards the Atlantic. The first non-zero digit and everything to the right is significant. And I think this every single time I do significant digits, because honestly, in pure math, we don't use significant digits quite as often because we're doing things more theoretical and not based on actual measurements. But this is definitely something you need for future science and engineering courses. We want to identify the number of significant digits in each number. Our first one, 72. Notice there's no decimal point. So my decimal point is absent, which means that I'm going to start at the Atlantic Ocean, which is the right side, and then work my way left. As soon as I hit a non-zero number, I'm going to start counting significant digits. So coming in from the left here, I immediately hit 1 and then 2 non-zero numbers. So this is going to have 2 significant digits. In our next example, the decimal point is present. So I'm going to start at the Pacific Ocean, which is the left side, and work my way to the right. The first non-zero number I come to, and then everything to the right of that is going to be significant. So coming in from the left, I immediately hit a non-zero. So I have 1, 2, 3, 4, 5 significant digits this time. Our next example, 1,302,000. We do not have a decimal point here. Our decimal point is absent. So we're going to start on the Atlantic side, which is the right, and work our way left. Oh, the first non-zero entry coming in from the left is 2. And we're going to start counting here every digit to the left. This number has 4 significant digits. I think I'm going to do just one more. In this last example, our number has a decimal point. So a decimal point is present. I'm going to start on the Pacific side, which is the left side, and work my way right. And I'm going to start counting significant digits at my first non-zero number. So coming in from the left, my first non-zero is 1, and then I'm going to count all those numbers to the right. This one's going to have 3 significant digits. A number that represents the result of counting, or a number that results from theoretical work and is not the result of a measurement, is called an exact answer. And that's what we like to work with the most in math, especially as we get into higher level math. Most values obtained for trig functions, however, are approximations, right? They're things that we've gone out there and measured, and we only can get so close with a tape measure or even a computer. So virtually all measurements are going to be approximations. Well, that leads us to the question on how do you approximate or round correctly, since your answer is no more accurate than the least accurate number in your calculation. So let's talk about, as we're measuring angles in degrees, minutes, and seconds, how we would identify significant digits. Well, if your angle is measured to the nearest degree, that's 2 significant digits. And that's regardless of how many digits your degree is, because we could have, 1 degree, 12 degrees, or 123 degrees. All of those count as 2 significant digits. Now, if your angle is rounded to the nearest 10 minutes or 1/10 of a degree, if it's in decimal notation, then that's 3 significant digits, because you're getting 2 significant digits for the degree portion and then 1 significant digit if it is rounded to the nearest 1/10 or 10 minutes. So we're talking about something like 12 degrees, 30 minutes. See, those minutes is a multiple of 10, or 12.3 degrees. I do want to be clear that those two are not equal measures. I'm just trying to write easy numbers here. If we're rounded to the nearest minute or nearest 100th of a degree, then that's 4 significant digits. So that would be something that looked like 12 degrees, 34 minutes. See, the minutes isn't a multiple of 10, or 12.34 degrees. If our angle is measured to the nearest 10 seconds or nearest 10,000th of a degree, that's 5 significant digits. So this time, the degrees can be whatever, the minutes can be whatever, but the seconds are going to be a multiple of 10. So something like 12 degrees, 34 minutes, 50 seconds. Or 12.345 degrees. We're rounded to the nearest 1,000th. And then lastly, if our angle is measured to the nearest second, and it's like a 2-digit second that's not a multiple of 10, or to the nearest 10,000th, if we're keeping it in decimal form, then that's going to be 6 significant digits. So something like 12 degrees, 34 minutes, 56 seconds, or 12.3456 degrees.